I also want to make a video for 1.7. I'll probably split this up into 2 videos like I did the previous one. And again, I want to show you how you can use a calculator. I do not expect you to use a graphing calculator that you might see some friends have TI-84. I'm going to show you how to use Desmos and Desmos.com. So if you notice, we have equivalent, which I actually brought this idea to your attention in 1.6 because two expressions are equivalent if they're both equal everywhere. So as long as those two values are equal everywhere, then we say that they're equivalent. And it's very useful to do this. And the reason why it's useful is you might look at expression 1 and say, okay, well, if I'm looking at this expression could be helpful if I'm doing something. Well, expression 2, even though it looks really, really nasty, it might be useful for something else. Or if you simplify them all correctly, you'll get it down to this. Well, let's see if that works. Well, if we look at the expression 1, the first thing you should do is distribute. So I'm just going to show my work down here. So that's equal to 3x. 3 times 8 is 24. And then subtract 7 from it. Well, now you can combine like terms. And that's equal to 3x plus 24 minus 7 is 17. Same thing, right? Then you can do the same thing with this. Now, what I would probably do is distribute this minus to each term and move things around. For instance, if you were to rewrite it, it would be 5x minus 2x. And then I'm going to write the plus 20, because remember, you can move things around with addition. That's called the commutative property. Minus a negative turns that into plus 3. So as we then simplify this, well, 5x minus 2x is 3x. Well, 20 plus 3 is, that's 23. That is not the same. So which one of these expressions is equivalent? Maybe I'll just type it out. Type out. Expression 1 is equivalent. Because you can see I got 3x plus 17, whereas over here I ended up getting 3x plus 23 for expression 2. Now that's nice and all if you understood everything I did. Well, what if you didn't understand everything I did? Could you use your graphing calculator, or in my case Desmos, to show that? And that answer is yes. Just go to Desmos.com. Just show you how I typed it in. Desmos.com. And it'll take you to the graphing calculator. You just click right here. And you can type in the equations as you're given them. Maybe I should scroll over so you can see where I'm typing. You can click right here, click here, and start typing. So I'm looking at 3x plus 8 minus 7. I'm going to write the next equation. Excuse me, I should say expression. The 5x plus 21. And then minus was 2x minus 3. So also notice how nice, and I like how dynamic this is, that I can actually look and match the red color with the red graph, the blue color with the blue graph. And what I want to see is which one of those is equal to 3x plus 17. And you can see that now it's a green graph, and if I click here, it hides it from me. So between which equation does the green fall on top of? It falls on top of the red one. Therefore, the green and the red are equivalent. Every x value matches up. Now, there's another way of doing this, and if you're using a graphing calculator, you would probably do it this way, where you would look at the table of values, and in order for them to be equivalent, for each x value, you have to get the same y value. So for negative 2, you should get 11. Well, down here, you got negative 2 equals 17. me look at the last table as well. Notice how this, I got -2 equals 11. So that proves that that green line matched up perfectly with the red line. Now, if you wanted to know, you can actually change the way the lines are drawn. Like if I click right here, I can make it a dotted or a dashed line so you can see the green and the red. And I'm sorry if you have red-green colorblind. Maybe I should make this like purple, or so you can see both the red and the, I don't know how good you are with seeing colors. But to me, they're kind of tough to see. So there's a lot of good benefits to using Desmos. Oops, I just deleted it. But the point that I was trying to get at, I'm not going to retype it, is you can use Desmos to show, that here. I'll just write it this way. I'll just use purple. That this and this had the same y values for every x value. The y values were the same. Now, if you're looking at my table, you're correct. There's no y here, but the values that we're going to fill in with the table are what I'm saying is the y values were the same or were equal. That's why we say that they're equivalent. So these two are the equivalent ones. Because if you plug in 0 for x here, you would have gotten 17. If you plug 0 for x here, you get 17. Well, if you plug 0 in for x on this middle one, you would have gotten 23. Maybe I'll go back to Desmos just one more time to show you. See how 0, I got 23 there. For 0, I had 17 there. Would have gotten 20, 23. Now, here's the other thing that confuses people. Is they say, well, I also got a 23 in this column. I just had 26 and 29 next. That is true, but they have to be for the same x value. So when x was 2, this is 23, and this was 23, whereas the 23 happened when x was 0. So they have to be the same x value. That's why I have this little for every x value. So let's look at exercise 2. And instead of showing you this method of completing the square, well, how about this? They're saying that Mariana went ahead and completed the square and got this. Decide if she was correct or not. So how can we show, using a calculator, that this is still the same as this? So essentially, here's our question. Is x squared minus 8x plus 3, so I'm going to put a question mark, is it equal to x minus 4 squared minus 13? So let's go to the calculator. Let me delete these what we did earlier. And you don't have to write y equals, you can just write it the way it was. X squared minus 8x plus 3. By the way, if you forget where the squared is, it's this little key, or you can hit this key right here, and it's in the keyboard down here. And then we're going to see if that's the same as where she had x minus 4 squared, I forgot what it was, minus 13. Minus 13. And again, let me scroll over so you can see, is I have a black equation and I have a red equation. Let me zoom over. What I'm going to do is zoom out so you can see more of the parabola. That's the name of this curve, by the way. So what I can do is I can go over here and I can hide one of the equations. And because every point of my red is falling directly on top of my black, then we can say that they are equivalent. Mariana did it correct. You can also look at the table of values. Change each of these to the tables. Is every y value the same? Does every y value match up with each x value? That answer is yes. So what does that mean? Mariana did this correctly. So maybe you just type it out, or I'm going to type it out, save me some time, or write it out. Because the curves match up perfectly, these two expressions are equivalent. So that's if you're looking at the curves. Otherwise, you can say because the tables match up perfectly, for each x value, the y values were the same. So what does that mean? It means Mariana was successful. She was correct. So maybe I'll write that out. Mariana was correct. So I'm going to stop the video here and do the second half of the assignment in a new video.